Okay, so here I started with the atom and I connected it to Dalton because he, as we all know, he's the father of the modern atomic theory. And next to him I put Avogadro because he was a fellow scientist and he came up with the 6.022 times 10 to the 23rd number, which is also known as Avogadro's number. And with that number you can convert to moles and find the molarity using grams and I'll eventually find the molecular weight. And down here I just put some other units of measurement, the liter, milliliter, and meter. Okay, so back up to Dalton and the atom. It's connected to elements, and well, actually, right here underneath, the anion is the negative charged ion, and the cation is a positive one. And elements can be categorized into inorganic or organic. I put carbon right there because usually that's what you study in organic. And at the bottom, I put hydrogen and oxygen because sometimes it could be considered both, so I kind of put it underneath both. And under inorganic, I just put the inorganic elements we were given: sulfur, calcium, nitrogen, sodium, phosphorus, chloride, and potassium. Okay, so back up to the element. In the element, there's a nucleus, and the nucleus is proton and a neutron. And in the outside of the outside of the element, outside of the nucleus, there is an electron shell, which has the valence, which is the outermost electrons, and well, I put electrons way up there. I probably should have put in the middle, but that's okay. And next to the electron, I put electron donor and acceptor, and then I put the oxidation reduction next to the donor because the donor basically gives away an electron and it reduces it and it oxidizes it at the same time. So I thought that was appropriate. And at the top, I don't know if you can see that. Yeah, at the top above electron, I put electronegativity because it's described, and it's also connected to atom, even though I don't have lines clearly. And I put that up there because it's described as the measure of an ability of an atom to attract itself to another atom. So I thought that was appropriate up there. And we can go back to atom and go up to the different kinds of bonds you can have in an atom, actually. Triple covalent bond, ionic bond, what does that say? Double covalent, polar bond, and non-polar covalent. So I put hydrophobic interactions. Let me scoot up. I put hydrophobic interactions up there next to the non-polar covalent bond because hydrophobic interactions are actually a type of hydrophobic interactions are actually a type of covalent bonds, and it's like they force together and to keep away like the dissolved molecules to minimize disruption between like hydrogen bonds, which is why I put hydrogen bonds right there, between the hydrogen bonds and like the water and the atom and everything like that. So I just put that way up there. Okay, let's see where we go next. Inorganic, we also talk about like carbohydrates, and carbohydrates you usually get like sugar and like protein type stuff for like energy. So I put sugars right down here, and I put polysaccharide and monosaccharide down there because they're like different kinds of sugar. Basically, they're just like mono obviously means one, and poly means more, so it's just like multiple like chained together. And then next to the carbohydrates, I put proteins, and proteins are the building blocks for amino acids. And glycoproteins are like a conjugate of proteins, so I put those right there. And next to the lipid, I put fatty acids because it's usually like fatty acids, and it's composed of carboxylic acid, which is why I put that right there. And underneath, I put hydronium and hydrogen because those are also common forms of, like, they're usually associated with acid, so I figured it'd be appropriate to put there. And I put acid at the top, and then I put base over here, and then I put pH up there because the pH determines like if it's an acid or base based on like the number and what color the litmus paper turns whenever you like test it and stuff. And I put salt over there because salt basically is like whenever there's a reaction between the acid and the base. So back to element. Whenever you look at an element on the periodic table, you can automatically find the atomic weight and the atomic number. Okay, let's go back down here. These are some of the functional groups: methyl, phosphate, sulfhydryl, alcohol, hydroxyl, carbonyl, ketone, aldehyde, carboxyl, amine, and amino. Next to phosphate, I put nucleotides because nucleotides are attached to phosphates, and nucleotides are like the building blocks basically for nucleic acids. So, I think I got everything now. Let's see, what did I leave out? Oh, the half-life. I couldn't really find nowhere to put half-life in my little thing, so I'm just going to attach it to the atom. And it's just like the time, the actual definition, where is it at? Half-life? Okay. The actual definition for half-life, I think, is like the time required for the concentration of a reactant substance to decrease half of its initial value. So I would assume that'd be next to the atom. Otherwise, I believe I have everything in there. Oh, no, I don't. I lied. Okay. So adhesion, I put it next to the atom. Because adhesion is like whenever, I think that's dissimilar. That's whenever they're like dissimilar, but they still cling to one another. And cohesion is whenever they're like the same and they connect to one another. And also off the element, I put isomer because isomer is like a different type of, it's like the same, but different structures. It's all made up of the same thing, but it's like a different structure. It's like an alternate form, I would say, I guess. And with that, there's like a water isotope, which is like that D word. I don't know, what is it? Denitrium, I want to say, maybe? The water isotope, but I know it's like 100% whenever the hydrogen's like 100% deuterium. I don't really know how to say that word, honestly. Can't even really remember it. And then underneath I put the radioactive isotope because it's also an isotope. And it is whenever it undergoes nuclear changes with radiation emission. Okay, I think that time I actually got everything, but this is my whole little flow chart. Next time I'll try to get it all on a poster board, I guess. But yeah, I think I got everything. What's under here? Oh, glycerol. I don't know where that came from. Okay, but glycerol should be down here. I would say off of, I guess underneath organic. I kind of put it underneath organic. I guess I can move it up some. Okay, because glycerol is like that colorless. I don't even know. All I remember is it really comes from like soap, and it's like tangy. Oh wait, it actually should be. I would think it'd be under acid really because it's like tangy in taste and stuff. I don't really know if it's acid or base honestly, but I'm not really sure where glycerol goes, so I'm just gonna put it over there for now. But it's the colorless, pale, odorless type of soap thing. It's a solvent, so I guess it'd be appropriate over there. But yeah, I believe I got everything in there. So once again, this is my little concept map video. Next time I'll try to do better. I don't really know how to do this. Hopefully you can even see this. But yeah, I'm Brittany, who tried to explain everything. But yeah.